did yesterday was an introduction to IoT system architecture and operating systems. Now we'll get to, oh yeah, please.
Hello. This class is being audio and video recording, so we want absolute silence in the room, because whatever you murmur, we get it in the recording. So if you are not interested, just leave the room, but I want strict silence in the room.
So today's lecture will be, close this, you can close this door, that way people can come that way. Thank you. That again. Restart. So our plan is to look at this topic on connecting smart objects. The smart objects are nothing but your IoT elements, okay? Devices, sensors, those kind of things. Now, if you remember that in your regular network layers, I'm assuming that you have some background, at least know about iOS, OCI, those kind of networks, layers. Okay, so similarly to regular network layers, we have also network layers for wireless sensor network. Okay, that way devices can talk to each other, communicate to each other, connect each other. Okay, and it's not just network. We also need some kind of protocols for that. There are huge amount of work has been done in networking for wireless sensor network as well as protocols. Okay. Now, MAC protocol is essentially pretty well known, but it has its own baggages. Okay. So, to be specific, two popular protocols that are attracted for this IoT environment, those are this is constant application layer protocol and MQTT protocols. We'll talk details on those things. Before that, we'll spend a few minutes on access technology, which essentially tells how network is being used to access the network before these protocols are applied. By the way, these two protocols are the application layer protocols. Okay. So you have physical layer at the bottom, then network layer above that, and other layers, then top layer is your application layer. And for IoT purpose, these two are more promising. So we'll be taking more detailed discussions on these two protocols today. Now let's start with access technology to begin with. Now, smart objects are things, the same thing actually. Things and smart objects, they are all same. So we have finding a trend in which size decreasing, power consumption is also decreasing, processing power is increasing and getting complex, communication capability improved. Those things are traditional things you always hear in any smart object. So I'm not discussing details on those things because it's written there, you can read it. Okay? Now, this is a typical device. It's pretty constrained with memory so that it has to reduce power consumptions, energy consumptions. So this one shows actually wireless sensor network deployment and the communication among them. They are typically in large numbers. Okay? And for IoT, in ordinary wireless sensor networks is different. Okay? That also I'll talk when the time comes there. But all these sensor nodes, they have limited influences. Okay? They have limitations how the network will be designed and deployed. that essential talks about the significant challenges for IoT. But the good thing is that you learn in this class, that this lecture particularly, that there's a difference between wireless sensor network and IoT in terms of deploying protocols. Now, hold on to that. Now, these sensor nodes are large in numbers, okay? And we always look for improving the accuracy, their life. Life means battery life. If battery is gone, then life is gone. Battery is gone because of unnecessary activities being there. So they have to be spending less energy to sustain their life and become more reliable, because wireless sensor network is precisely a group of networks. They act together. It's not single element. And also we talked yesterday, that communication pattern could be event-driven or periodic. Okay? Then I'm hoping that you know that this is transmit, listen, those cycles. Okay? Then in addition to that, they also have an automation arranged for self-healing, self-protection, self-optimization. So this is a little bit subtle things. Self-healing means suppose one sensor dies, then other sensors can cover it. Suppose you want to know the temperature for this city Warangal, then there are hundreds of sensors around, and if 1 or 2 or 5% of sensors die, then other sensors can still send the temperature, could be averaged out. Just an example. And in the meantime, people can change the bad nodes. Self-protection, if something is really bad, kind of attacked, then this has to be isolated. Then other things should know that, okay, this has been affected, so they can just say, okay, we don't want to deal with you until you are reliable. Okay, that way self-protection is also automatically handled. And self-optimization means you don't want to use all of them at the same time, maybe a group of them, as long as they give a result to meet the accuracy, they continue to work that way, they optimize so that the energy consumption, coverage, reliability is enhanced. The communication criteria depends on the range, meters, in case of Bluetooth, in case of other protocols and other arrangement, they have up 10 kilometers, 100 kilometers, things like that. Then frequency band to be used, power consumption, topology, all these are well-known discussions under networking and wireless sensor networks. Now, the purpose of putting this slide here is to tell that when we evaluate a particular technology and protocol, we are aware of is it improving or is kind of same. We compare in terms of range, compare in terms of power consumption, and so on, and different topology, and evaluate it in terms of other parameters. But the fact that coming to us here is the nodes are highly constrained. That is a challenge by the smart object networks. Okay, coming back, the technology called IoT access technology. There are many actually. So I put only a handful of here, about half a dozen here, because they are more in use. We call that they are promising ones. There are 4 of them. Look at these 4 IEEE standards. Allianz have made and came up with this. This one is for the power line, and this is the beginning protocol, IEEE 802. Then the second one is actually used for smart cities, smart grids. Even smart grids also uses this power line protocols or access technology. Sometimes you find the term being used, access technology protocol, little alternatively, but they're not same actually. Okay, but some of them have capability to do the other one. That's why people loosely talk about access technology protocols. Okay, now the other 2 promising are, this is very promising, it's long range. We have actually practically used these things in some of the projects back there. This is a low power. This is wide area network. We'll discuss a little bit more about that as we go. Then this is actually very narrow band IoT and other variations. They're all licensed spectrum. So quickly we can review these things before we jump into those our targeted protocols. This particular slide tells us various technology, access control technology that is now being used. They have different range. The range is given in your x-axis. That's another actually fine where the range is even 100 kilometers. But this one is kind of medium range. So starting from few meters until more than 10 kilometers. And y-axis essentially is talking about the bandwidth, low bandwidth, high bandwidth, and medium ones. So as you see, the Wi-Fi is between medium to high, but only 100 meters or so, could be not more than that even inside the house. Okay, tens of meters, not even 100 meters, okay. Besides, you have got, Bluetooth is again about 30 feet or so, okay. Then cellular network is coming, little higher range. As 5G, 6G is coming, it will go a little bit further to our right. Then this is another popular one, Zigbee, which is a medium range and typically used in the corporates and big buildings. And this low power wireless area network is the one which goes actually several kilometers. Okay? Then you have licensed spectrum, unlicensed spectrum. Licensed spectrum are applicable to IoTs for long range applications, whereas unlicensed one is for industrial, scientific, and medical purposes. Now, for wireless IoT standards, the new technologies that has been come off is your optical network. Okay, IoT for optical or basically optical network for IoTs. It goes to up to 100 kilometers. Okay, and the previous one you saw they are kind of being here because we are scoping it. We are zooming in actually. That's why they gone to this side, and this LoRa and other things were longer ones. In the last picture, they came as a medium range, and this one coming this side. Okay. Just to give an idea that these are access technologies that you don't kind of misunderstand, and we can separate when you think about MQTT and CoAP, you will figure out where they are placed versus what we know at this point of time. Then topology point of view, there are different topologies from star, mesh, and peer-to-peer, and they look like this, and some ideas about the, say, long range. Typically, they go for the star. Medium range, they combine star, P2P, and mesh. The indoor Wi-Fi at home is star. Outdoor, it could be star, mesh. Now, you will see that all these devices, the nodes being used, depending on the use, their battery life is varying in years. I think yesterday, Dr. Sai Prakash has told few things, so I don't have to repeat that here. Okay? Now, let's come back to the constraint devices. Device constraint means they have limitation in terms of bandwidth, in terms of power, particularly more in power and memory. Okay? Now, the three classes. Class 0 uses small, tiny amount of memory, okay? And they do not have really any IP stack or any security mechanism. So pretty thin, we call them as class 0. Okay? Example is push button. You want to send some signal, you are triggering something, you want to make sure that information is known, those kind of things. In class 1 is a still similar range of memory, but with a little or optimized IP stacks. That's what basically the CoAP. We'll discuss that in detail. Then the class 1 also can engage the network without a gateway. Okay? Then you go to class 2, higher amount of memory necessary, more energy consumed, and they have a full implementation stack. Now, do you understand the implementation stack means? All the network stack, wireless sensor network stack. Just like a regular networking 6-layer stacks, they also have some stacking provisions. Stacking means you're enhancing the capability. You can control a lot of things, okay? Now, most of the smart power meters, they have the class 2 category. ZigBee IP is based on the protocol or access control technology 802.15.4. Okay, and this is what the stack: physical layer, MAC layer, adoption layer. Then you have got all these protocols over there. What is this RPL? Routing protocol. Okay, routing protocol is here. Then these two, what is this UDP? You know what is UDP? UDP is a wireless one. TCP is wired one. So this is wired protocol, this is wireless protocol. And then you have got ZigBee IP, which is essentially at the application layer. So you can say that these protocols, that's basically mostly we'll be using for the IoTs. Okay. Now in addition to this information, additional information is actually in adoption layer, we have a support of 6-LoWPAN technology. This is actually low power area network, which can go long way. Okay, so that is also being here. You will have all these slides with you anyway. So now, for us, you can have actually multiple approaches. Now the beauty is the ZigBee IP, as you see here, okay, it has a provision that it can be utilized to connect wired network and wireless network, both. Okay, and sometimes I'll show you later just pure IoT. You will not have TCP, you have just UDP. Okay, you may have this, and this one, this RPL, then UDP, and go to application or to cloud directly. That is there. Now, 1901.2a is essentially your power line ones. And the applications are smart metering, public lighting, that you see all the lights they put on the your street lights, which they control. That is typically these power line ones. Okay. Then electric vehicle charging stations, microgrids, renewable energy. All these actually falling under this power line category. They are narrow band typically. Yeah, let's take a look at the LoRaWAN. Okay. Now, in LoRaWAN, the range is actually 10-kilometer range. They use a security AES 128 encryptions, end-to-end encryptions. They are scalable. Okay, that's why it is very popular, and it's open standard. That way, you can develop anything above it. Is available. The code is available, and industry standard is something that is adopted by other industries. Okay. Now, your low power refers to actually LoRa refers to which layer? Physical layer. Okay, physical layer. So you have frequency bands, and the devices are connected to this physical layer, where the modulation is also part of that, which is going to LoRaWAN. Okay, this is a low power wide area network. Okay, and the protocol that is being focused on MAC layer. Okay, there are a lot of discussions, and for many years people talked about using MAC. Hopefully we can have some time today to look at the MAC and the challenges that MAC has for IoTs, and the relationship, and it is a weight. All those things are there. We might be able to discuss few things there. Okay. Now, as you see here, we have same physical, this kind of physical layer, MAC layer, then this is your application layer.
Actually, the link has gone and we are unable to record.
Oh, I'm sorry. Oh. Where to go now? Here, right? Okay. I think we are here, right? This is the one. Okay. Sorry about the interruptions. Well, maybe you can remember this thing. I can record this thing later if necessary. Okay. So, low power, okay, low power access technology, LoRaWAN, is actually one of the wide area network. Okay. Then many devices are being deployed within the technology for IoT network. And we have actually last semester we implemented and we did experiment by traveling several kilometers to check it. And some point the site is difficult, so we went to a point like in a mountain top to make sure that we are not distracted. Okay. Now, the LoRa is having end-to-end encryption for security point of view, and it also offers scalability, and it is open standard and industry standard. Means pretty much it's very much stable at this point of time. Okay. LoRa is deployed in the physical layer, and the layers are basically unified and standardized for interoperability. If you remember yesterday we were talking about interoperability, LoRaWAN is popular because it offers that interoperability quality. That way any device can adopt it and go and make the access convenient a physical layer. And the architecture looks like this. Particularly look at these two layers with the gateway. MAC is like like gateway, and you can have, this is the end servers, then you can connect directly through a gateway or directly. Okay, you can have some roaming stuff, they go to network server directly here, or they can connect to a intermediate server and then go to end server. Okay, so both physical and MAC layers, they allow the technology to cover a longer distance. Okay, when they do that, they can change even the data rate. Sometimes you will see, you can see pretty much all the time that okay, when you want to cover long distance, your data rate is low. Okay. Back to the point where you're supposed to start the work. Okay. We have constant application protocol and MQTT. There are two protocols at the application layer. These are IoT application layer protocols we are going to talk. You still have the physical layer, MAC layer that we saw in the last couple of slides. They're all consistent using IPv6, means opportunity for a large number of devices to be included and provide scalability. Usually these two using UDP layer, wireless ones. So why constant application layer protocol? Why we care about it? Okay. Now, in typical development of technology, internet. So by the way, do you know the difference between internet and web? Everybody? Internet and web. Sometimes we talk loosely. Internet is same as web. What is the difference between that? Internet is an infrastructure, physical infrastructure. Web is a service, a software. One is hardware infrastructure, web is service or software. One uses other, or other gives service through www. Okay? Now, the web technology, traditional web technology, that do not consider memory, energy, and computation constraints to embedded devices. Why? Because they are a service provider, a software. When they write a program for certain purpose, they never look into the energy, memory impacts. That's the reason. Okay. Now, there's no consensus among manufacturers, a common application layer. At this late, you will find application layer is a mixture of many things. So there is no standard agreement. Okay? Then these two situations, they essentially push the scientists, engineers to think about a common application layer protocol which will be resource constrained and applied to IoTs. Because typically they don't, so somebody has to do that. That's where CoAP has been coming up. Now, CoAP provides request and response interaction mode. HTTP also does that, but there's a difference. We'll talk. Okay? They are more cryptic. They are not as elaborate as HTTP. They're pretty much they're trying to satisfy the service is basically pretty large. These services provided to both networked, wireless, and other infrastructures. For other infrastructures, but we are looking for a CoAP technique, communication. Both have request and response. The request goes, response comes. Query goes, response comes. But CoAP is special. We'll talk about that. And again, as we talked before, CoAP is based on UDP, supports asynchronous message based on request response protocol for the applications. So application layer is here. Then these are the background, basically more detail looking inside. Okay? And CoAP has low overheads compared to HTTP. They have a uniform resource finder, URI. You know what is URI? URI has two parts, URN and URL. You all know what URL. You type URL, so definitely know that. There's URI is basically a combination of those things, two types. Okay? So, yes, particularly the new students, they have not taken this course, maybe it's useful to them. Okay? Now, typically, the URI is nothing but sequence of characters. Just like when you type URL, that's a sequence of characters. Same thing here, and these characters essentially refers to certain contents, documents. Those have been stored in some servers. Sometimes use proxy and caching possibility. Proxy caching means there's not necessarily there's only one place you go and find the content. The content could be there on multiple places, cached on the way. If you remember cache memory, similar concept over here. Okay? Let's basics of CoAP. The CoAP messaging model is a typically request and send, request response model. Now, request response are carried as a message. I'll show you some pictures next slide, I believe. Then your method, this method coding is code for request and response code are very cryptic in terms of get, put, post, delete, those kind of things. And typically HTTP also has got similar cryptic code. Code means command actually, simple straight line commands. Okay? Now the client parses this URI to get the host of which server has that, which port has that, and find a path to go there and find it out and bring it back. Okay? Intermediate caching is sometimes you cache it on the way so that next time the same request comes, you don't have to go back. remember that sometime you've been telling that, okay, you clean your cache. When you clean your cache, all the proxy addresses are missing. Then you spend more time to get that there. Again, cache build up. Okay. The resource discovery is an interaction between machine to machine, okay, which are being done using core link format. I think this may be kind of a delink to what we talked so far. Okay. Core link is actually another format. Okay. Just ignore for the time being, because I have not discussed those things I have before. In case you find kind of a delinking, don't worry about that. Yeah, here is actually the infrastructure of CoAP. CoAP communication in IoT. As you say, this is a sensor, IoT sensor here. This is where you can be workstation, could be a tablet, or could be a smartphone. You would like to control this. Now this is a cloud. And this is your device. You call it gateway, or you call it actually sensor's bus. The sensor is essentially controlled by this. But really, sensor controlled by anywhere from this area. Okay? This is only the fact that it can connect the sensor directly to this one using wire or could be wireless. In this example, it showed wire, but not necessarily. It could be wireless. Okay? The Raspberry Pi, it provides both wire and wireless facilities. Okay? Now, where the CoAP comes in, CoAP protocol is send a request response comes between these two. Okay? And the cloud is very interesting entity. You can call that, okay, this is the area. You can put anything here in cloud. They can float. There are thousands of servers connected there. Cloud is not a physical, in a way, is a concept that all the servers on the ground, they are not really in cloud, but they are on the ground, and still you feel that they are actually, why they give a cloud sign there? For the reason. Yeah, so that you can, as if you are seeing things above you, and everything looks like a black box, there is no specific structure defined. If you cannot define something, you put that in a box, black box. So here cloud is a black box, in that sense. Okay? Now, this particular picture, GPIO is actually your real wiring, general purpose input-output lines, cable connected from certain sensor to Raspberry Pi. But you can have a simple wireless communication also. Okay? Now, this is where actually CoAP is being used. The device with the sensor is talking to cloud, storing the data, and these users having either tablet or workstation or smartphone, they can go to the cloud and get it. Okay? More pictures coming. Now, before that, what are the features of CoAP? First of all, it is not that complex compared to its counterpart, TCP. It's connectionless, means no is wireless. Message could be two types, conformable or non-conformable. Okay? That is, conformable means you send a message, is guaranteed to be received. Okay? You are guaranteed to be getting response. And non-conformable is you are not guaranteed to get a response. Then you get a response through acknowledgement. Sometime you reset it also. Now, it's possible that using CoAP you can have either one-to-one or one-to-many requests. Okay? Then block transfer for large files, possible, and this is the example of a URI. Set of character and paths and so on. And they have a certain format, first host, then port, then path, all those things. When you implement CoAP, all this will be useful. Okay. This looks a little bit too weird now. Yeah, this slide is kind of messed up. I don't know how it messed up. So essentially, this slide says there are 12 or 14 design requirements for CoAP. When you design a CoAP, you have to consider various aspects of it. Okay? I can't read even those things. Let's see if I can. Yeah. No, I have to take it. What happened? This guy here, anybody? Can you call this person who was in charge of these things? This guy was here. Can you pause it, please? Can you pause it? Pause it. Yeah. Sorry about the interrupt. Now, the communication example that you see here, let's say your client, say Raspberry Pi, to which sensor is attached, is your client. Cloud is having server. Now, Raspberry Pi, the client, sending a conformable request, such as get. Get what? Get temperature. It's sending to a token. This is the identifier, conformable identifier requesting to get temperature, token generated. Then server gets it. Then cloud with server receives data and returns acknowledgement message with URI of updated resources. That means with this it knows where to get it and temperature is available. Okay? So it's so simple. Because of the simplicity, it has been very popular and being used. Now, another example here is a similar example, but things could not be found. So no, it's basically not found is essentially responded. Yeah, something is wrong that they have been moved this way already. And non-conformable requests are typically not guaranteed. Request goes, nothing may come out. Then you have to make reset. The message transmission is always asynchronous. There is no clock necessary between endpoints. Okay? And without security endpoints, okay, without security, the endpoints that connect both the client and the server with the port details is something of specialty for this CoAP message findings, which means why they do that? The purpose of doing that is to make least overhead. Okay? And if you want to include security, it's possible, then you have to have several certificates such as this. They have been defined here. Okay? The certificates have been defined here. Now, the format is, it is a 4-byte message having various components such as which version, how many bits, is message type, is conformable or non-conformable, acknowledgement reset, basically you need 2 bits for that. Then this is the token length. If you are using a token, then the length of that has to be mentioned here. Okay? If not, then this could be all X or 1, then nothing has to be there. If something is there, then it has to find out it from next layer. Code that is talking about this, all those code, get, post, all those things, the requests are eventually 1 to 10 bits, 1 to 10 of them, then response code could be much larger, but up to 256 is 8-bit only. Okay? Then message ID is 16-bit and token is optional size. So what is saying that the message format, there are many examples you must have seen in computer technology, so it is similar to that. Now, if you want a reliable transmission, you have to use conformable CoAP header. Okay? Then sometime you may fail to get things because this is pretty least overhead, sometimes may be unreliable, but quite often they are successful. And the advantage is you get because of the least overhead, you get all the mileage that one can expect from least constraint attached to the system. And in that scenario, it's possible that some of the messages could not be responded. Therefore, you may have to go for a reset mode. A reset mode means essentially you have to restart once more. Okay? That's a possibility that you may have to wait for one certain amount of time. So often the technology uses a timeout, asynchronous timeout, which means you send a request, you did not get in certain time, 2 seconds, that actually says it's timeout, then you have to send another request. And like this, maximum number of times you can do 4. Okay? And the gap between them would be 5 seconds. Okay? And dealing with packet loss. Some of the slides somehow have been kind of changed. We have to see why it has been done that, but I'll fix it before we put that to website. Dealing with packet loss, the approach will be stop and wait. Okay? If packet is lost, wait for some time, then resend it. Okay? The application of CoAP is a smart grid, building automation, and many legacy protocols may be mapped as a CoAP resources, and quite often even CoAP has been integrated to other devices and protocols in a way to make their life easier. It's possible that you do not have a consistent protocols all the way from end to end. You may have CoAP in between. Wherever you have heavy load, you want to release much of the loads overheads, or there's a need to address the constraint capability. That also you can do. CoAP can do multicast, okay, so that a group communication is possible, like several sensors to be given command to do certain things. So the second one is will be done by 11 o'clock, right? When you start 10 o'clock, right? You can go up to 11 and finish it, right? Oh, which is important? Tea is ready or we are ready? We have to be ready for tea, right? Right. Now, MQTT for IoT, there are a few slides left actually, is a concept we're talking about now. How is the application for IoT? We'll discuss that. We'll have a comparison between MQTT and HTTP. Then machine-to-machine connectivity using MQTT. Okay? What is MQTT? Okay, is a lightweight. Lightweight means using low bandwidth. Okay, it's a messaging protocol like the CoAP for machine-to-machine communication. You know what MQ stands for? Q, telemetry, transport. There is no Q though. Its name is machine queuing, but there is no Q. That's interesting. It's a classical name. This particular technology, a protocol started by IBM. The name was there, so when it was adopted by, they released it for the open source. When the others used it, they did not take out the Q. Okay. Initially, whoever coined it might have thought to put as a queuing message, but did not have to do any queuing. Okay. And the technology that uses is publish subscribe mechanism. What is that? It's very simple, publish subscribe. Suppose you want to send something, you publish. Others are interested in that, they pick it up from there. Okay. So you publish in library, then others pick up library. Just like books have been there, then you can publisher put the book in library and user want to take and use it. That's how the communication is used. And healthcare, Facebook, environmental applications, they're all using it. Because Again, because of thin, lightweight, and simple messaging, publish and subscriber, asynchronous, okay, it enhances the battery life. And for IoT, that's very important, it's a big thing. All these pictures have been moved this way. I saw checked last night, it was all good. When you copied this to this one, that all changed. That was, yeah, we should have, doing these things ahead of this class, not after the class, okay? Anyway. Now the concept-wise, again, message publish and so as you see here, you have to basically sleep and look at it. Okay, these are the sensors the publishing. Okay, and these are the receiver. They are interested in more than one or more published items. Okay, so sensors publish, IoT sensors publish. They put that into different library. They are arranged in a tree form or different other forms, where the user who are supposed to get the message, they go and check what they want. When one user may get multiple items from there, published items. The 3 levels of MQTT, we call that quality of service. Okay? Level 0 is the best effort is made to get the message out. So message is sent for public to publish only once without expecting acknowledgement. Obviously list over it. Level 1, at least one, but with acknowledgement. Okay, but the acknowledgement not retransmitted. Okay, if it's not received, not received. It's better than the first one. Level 2, exactly once you can put extra control signals. Request to send, publish, clear to send, message, act, they're all provided there, which means level 2 is much more advanced and reliable compared to level 0, level 1. Then question, why you have 3 levels? Because some scenario, this is good enough. For some scenario, you need it. Okay? Now, about message. When you publish the message, what happens to that? Is message stays there or message deleted? Both are possible. Sometimes message, typical message could stay there. Sometimes message need not stay depending on type message. Sometimes message stays there and if the same subscriber comes back and try to pick it up, it is available there. Sometimes new message comes at update also. So all those possibilities are there because that is being arranged by the middle layer, which you call the library. Okay. Then there is a clean sessions and durable sessions. I think I just told that. The client set a clean session, flagging it as 0 or 1. 1 means client subscription are removed when client disconnects from the server. Okay? Flag 0 means subscription is durable after client is disconnected. Then client can come back and renew that. Okay? There are 2 more instructions here. Willis. What is Willis? At a connection, a client can inform whether it has a interest or will means will, same as interest, okay? Will or a message that should be published if unexpected disconnected. That means will is saying, okay, I'm sending something, but if I'm disconnected, don't throw it away. Okay? And if I'm disconnected, let me know. Because he has no idea, if there's no acknowledgement, he cannot know that. So if disconnection happens, then he has to be told. Then tree is actually where all those messages will be organized. Okay? It could be tree. There are actually new papers are there. I did not include it here. I saw them last moment. So there are other ways you can list them. And topic trees means, in fact, similar work we did several years back in semantic routing network, where we envision the time, which is implemented already in Google and others are implementing that, already implemented. So that time it was pretty new, and we decided to publish a paper where we validated that with experiment simulation. If you are making some kind of information in healthcare, it goes to the server for healthcare. Okay? So each server, each storage meant directly for the particular regions. It's not something, it's kind of vast, you can put all vegetables at one place. Okay? Potato goes potato place, eggplant goes eggplant place, things like that. The same concept also, they are being used here. There's a topic trees. Topic tree means all that, how they're connected under one tree. So one tree will have all those nodes together. Healthcare application, I have three applications actually here. MQTT applications in healthcare is like this. The patient at home has a wearable device which talks to your home monitoring appliances with the MQTT protocol, and the monitoring appliance equipment talk to message server over internet and is available here. Then analysis is done on that, smart analysis to saying with the condition of the heart, if it is a heart, ECG signal, then it says it is doing well or it is in an aggressive stage, then it gives the information to doctor, doctor examines and tells back the patient what to do. Okay? So sensors are with the patient. Okay? MQTT is here. That means the patient's data, his data is provided to a tree, and your hospital side is a subscriber who is picking it off from the tree and analyzing. After analyzing, it alerts the doctor and information to the patient. Energy utilities is similar concept. Let's go to the picture. Hope it's not changed. Yeah, it's saved. It's not bad safe. Okay. Now, what you see here, all these triangles, yellow triangles, essentially these is actually homes, residences. They have got many devices, sensors. So the house is instrumented, and this instrumentation is particularly energy-related instrumentation. Heat, air conditioner, we call the HVAC. They are being monitored regularly. And that data to wireless tower is given to a virtual power plant. Okay, I'll talk about it soon. Now, the communication from here to there is actually MQTT. Okay, then this side what you see is your power plant and transmission substations. Power plants, they're getting power from different sources and try to provide. But a virtual power plant is actually a software tool. Okay, looks like this. Details are here. The database, it has plant applications, WebSphere application servers, and your WebSphere MQ, and monitoring management. All these things are happening in the power plant. Typically, what you see in the back end is designed in a simulation tool over here, which we call virtual power plant. So virtual power plant job is, it knows how much power generated, how much it transmitted. At the same time, it also keep an eye on these consumptions. Depending on the demand and supply, they think what is to be done. Its back has to be controlled, or more power is to be in demand provided there. What else? So all those activities are possible through an integrated arrangement like this. Okay? Other application areas, There are point scale solutions too. We know what is point scale solution? Point of sale solution. When you go to all the market, they have the electronics weighing machine. It's connected to also, okay, to MQTT facilities. Okay. Then all the slot machines in gambling. If you have gone to Las Vegas or you have heard about it, people think, okay, all the slot machines are independent. You can go and play and kind of win. It's not that. They are always monitored. Okay? Point of sale is typical, say, go to grocery store, any food store. Yeah, that is possible. Yeah, that's also extended to that now. That's possibly extended to those things.
All the objects are.
Yeah, right. Then, yeah, you can even do, okay, where you get the produce, where it's there in the store, and then your cart will go there, then you can basically come back. Yeah, you just all do it, put it back. Everything is taken care of. Yeah. Then, yes. Now, that's actually showing here. The slot machines are continuously monitored, and they see what's going on in each slot machine, how much is winning and how much is losing. They keep track of that. Everything is automated already. So gambling devices are distributed in the casino centers, okay, and they all that independently distributed but connected to central server. And analytical tools are applied to see whether which slot machine is doing good, not good, and why they are not doing good. Are they making profit or not? Okay. Preventive maintenance of automobiles, your car maintenance. The sensors there, they measure the quality of oil. They say, okay, oil change time is there. Wear and tear of tires. I give a nice example actually. We had tires 6 months back, one of the SUVs. Then we found that something is wrong. So when I was driving, it was giving some sound, regular in a periodic manner. And when I come out, look, and nothing is there. Then I tried many things, then finally went to the store where you change the tire. This guy came with a gadget, simple gadget like our gadget. He just took it there, did like this, then read out. A part of the tire is actually damaged, so it has balled out. So when you go in high speed, it basically gives a periodic sound. So the technology has gone to that far already. This is exactly what application of that. Okay. And environmental monitoring using remote sensor, same thing. So essentially, MQTT being a so low overhead, at the same time it provides bunch of advantages, and many applications you really don't need to be hurried. You don't need a speed there. You need more automation and more observance in a distributed scenario. You can use it. That's why both CoAP and MQTT has been popular and important for IoT technology. So comparison between MQTT and HTTP. Your MQTT data centric, as you saw, send message with data, and HTTP document centric. Pattern is publish, subscribe, whereas request response. And I wouldn't compare it CoAP because CoAP is similar to HTTP. This is different. Complexity is simple, more complex. Message size very small, large. Okay. Then service level, 3 qualities we saw, and here all messages are got same level of services. Extra libraries, there are few, both C and Java, whereas you can have many things, JSON, XML, and many more. Data distribution, support 1 to 0, 1 to 1, 1 to n, this is 1 to 1. Okay. What exact data distribution means? Supports 1 to 0, 1 to 1, 1 to many, means subscribers. Here, 1 to 1, you make a request, you get the response. But there, you make a request, you may not get a response. Or you can request, get response. You put something, publish something, many people can subscribe it. That's the thing. Okay. Yeah, that we call that tree. Now we call it a tree. Then MQTT brokers. So they more popularly, MQTT is known as broker actually. Because it's like broker, right? What broker does? What broker does typically? He don't own anything. Client is owning, say, look at a real estate broker. So client want to buy something, just go to this broker. Broker knows who has houses to sell or something to cars to sell. Then he essentially to connect them and get the commission. Okay, here same thing, data is in, yeah, it's similar concept, right? So it's called that MQTT broker. It's essentially a broker is a server that implements this protocol. It mediates communication between MQTT client and applications such as remote sensors, enterprise layers. So same way actually. And these are some of the references for the brokers and other actually, there are other brokers actually here. Okay. Yeah. There's another example, but it's very simple example, is a transportation company wants to upgrade the truck monitoring systems. What happens actually earlier, each truck, they have a different kind of monitoring systems, different protocols. It is very difficult to keep CoAP for variety of protocols together by the headquarter. So idea is essentially to change that to all MQTT, they are all uniform, they have been, data is collected to wirelessly and put in certain places on the way they're traveling because they go thousands of miles, 100 to 1,000 of miles. They put there and headquarters literally take those data and make analysis. So that's basically says why and what. So publish subscribe configuration could be simple as this, a broker having subscribers as well as publishers. Trees are here, okay? Or you can have multiple brokers and to extend it. So we just printed the smart object connectivity. In particularly, we talk about CoAP and MQTT protocols for IoT. Okay, so there are more other things you can actually look into yourself if you are interested in this area. Okay, and that's basically the last slide. If you have any questions, please feel free to ask before you getting tea. Huh? Energy in the beginning? Which one? Just to tell me stop. This one?
Previous.
This one?
Previous.
This place?
The second application after healthcare.
Oh, okay. This one. Okay. This one?
Trying to understand exactly how things are controlled.
Yeah, I can explain it again. Okay, no problem. Now, what the purpose here? Purpose is to find out the energy consumptions and control it. If you need more, okay, yeah, two parts. Part one is we have generators, okay, different kind of plant, wind plant, then thermal plant, a nuclear plant, then other plant, hydraulics plant. They are all generating power and coming to transmission center. And for transmission center, forget for a moment this is there. This energy line is, transmission line is going all the way here, forget everything. And all the houses connected. That's typical what you see now. We have most places in India like that. Now, what happens now with this, if you consider the houses are the sensors for IoT, and for them, this is actually big server for energy server. They want to getting energy from there. So,
Actually, are we just tracking on the consumption?
oh, okay.
Or are we regulating or controlling?
Both. Okay. And who helps that? This guy. So virtual power plant means as if you are creating, you can collect, okay, A, B, C, D, E. You can get A, B, C, D, E with their features there. These virtual entities correspond to each one. Then transmission subsystem also is part of this now. So you have everything is simulated environment. Okay? Then is also connected to information from here collected through wireless tower, and when you go here, each one, this looks like this. So the sensors are here keeping track of energy consumptions, how much energy has been used, how much is in demand. They cannot really find out demand here. You can only find demands at this point when you combine all these things. Individual people, they can only spend energy when they are there. They have no control on the demand. They can spend. But somebody looking the big picture, which is after collecting data, here can find out. It's winter, they need more heat, they're spending more energy. So demand is increasing. They can tell, they can decide even with the proper algorithm, it's okay, who has capacity to boost energy. Some may be not capable, some are already doing 99%. So they have on this virtual plant, they know who can, okay? And they can always ask them to produce more. And sometimes they are all into choking. They cannot. Then in that sense, they can say, they find out who is consumer is using the HVAC more. And they can tell them to control that. It is similar to example also the water distribution. Exactly same. Energy distribution, water distribution, similar scenarios. Okay. Anything else?
Sir, can you consider that as MQTT broker?
This one, this is the one.
Power plant, can we consider MQTT broker?
This one? Not really, because this virtual power plant is an instrument that standing between the transmission, generation transmission put as one side, okay, then it essentially find the demand and supply events. But broker is typically, when you look at this transportation, broker is somewhere in between. It's not, yeah, not shown there. Yeah, right. It's a communication basically. See, well, to make it more clear, they don't even, honestly speaking, they don't even look at the energy values. All that happens in between them is the data it's collected from here is passed to this side. Okay, after being stored in the tree. So tree is not shown here, but tree is there. Okay? Okay. Yeah, you can see, then I can start the next lectures. Okay, a little bit. I have to upload that.